The last third section of the class is about inductive reasoning. So far, we've really just been talking about deductive reasoning, and we focused on that in the second section, which we've just finished. While we go, in the first section was all dedicated to basic concepts, right? And so we just have to recall from our basic concepts when we talked about evaluating arguments with respect to whether the premises are true and whether the premises are related to the conclusion in the right way. Yeah. And the relation to the conclusion that we're talking about when we're talking about deductive arguments is validity. We're looking for whether the argument is valid or not. And remember that the valid argument is one in which if the premises are true, right, then the conclusions being false would be a contradiction with what's actually in the premises. Yeah. And so that means that it would be logically impossible for the premises to be true and the conclusion false. So that if we were certain that the premises were true, we would also be equally certain that the conclusion is true. Yeah. And then everything comes down to how certain we are of the premises. But again, we're really just talking about the relation between the premises and the conclusion. Yeah. Now, in inductive reasoning, it's different because an inductive argument is never such that we will find a false conclusion in contradiction with true premises, right? Rather, an inductive argument seeks to assemble and present evidence that its conclusion is more likely to be true than not, right? So it's just aiming to show you that the conclusion is probably true or more probably true than not in light of the evidence presented in the premises. Yeah. So it's a completely different ballpark or game, we can say, because we're not looking for whether an inductive argument is valid or invalid. Yeah. It's in the wider ballpark in the sense that, or it's in the same playing the same bigger game, which is actually arriving at knowledge of the truth, right? About what we don't know on the basis of what we already do know. But the route there is different, right? And the sort of, let's say, the degree of knowledge, right? Or the kind of knowledge that we arrive at is quite different, right? It's not what we call deductively certain. In that case, we have a kind of a situation with respect to the known thing whereby, it's possible that it's actually always still possible that it'd be other than what we think, right? Or than what we've arrived at. And so on some definitions of knowledge, which are very strict, right? According to some people, knowledge requires certainty. So that if you know something, you have to know that you know it. And that sort of ends up translating into you have to be absolutely certain. And it must be then impossible for you to be wrong about it, right? Remember from Introduction to Philosophy, that was Ghazali's standard of knowledge, and it was also Descartes' standard of knowledge, right? It's a kind of a philosopher's standard of knowledge, but, most philosophers, and even Ghazali and Descartes, recognize that in day-to-day life, we make decisions, right, on the basis of far less than that, far less than certainty. And so we have to, and so there's a sort of practical, or let's say, for all practical purposes, sense of knowledge, whereby we basically mean we know it well enough, or we're sure enough to say we know it and make decisions, right, on the basis of that, right? Even though we might always, even though we're not infallible, and it's possible for us to be wrong at any time. What we want to do is increase the probability of our being correct. So that comes in degrees then, right? Probability comes in degrees, and it's not a black or white issue like valid or invalid, right? An argument is either valid or it's invalid, but there's no such thing as something that's more valid or less valid, right? If it's invalid, it's just simply invalid. But if it's valid, it's 100% the case that there's a contradiction between presuming that premises are true and that the conclusion is false. So that's a complete different thing that we're looking at here then, because inductive arguments are either stronger or weaker, not valid or invalid. And to judge something according to, let's say, a quality or a feature which comes in degrees is different than judging something which is an either or matter. And it's a relative judgment. So we always have to talk about whether an inductive argument is stronger or weaker than some other point of reference, right? So it could be that the argument is stronger than it would be if, the premises were other than they are, right? Or it could be stronger than some other argument, right? We could say that the inductive argument that the conclusion is true is stronger than the argument that it's false, yeah? Something like that, but it's always a comparative judgment. And so inductive reasoning requires a more comparative and holistic, tentative style of thinking. Yeah. And for inductive reasoning, we're going to talk about 4 things in the course of this class. First, we're going to talk about analogical arguments, because in many ways, analogical arguments are the basis of inductive reasoning. A lot of other forms of inductive reasoning are sort of modifications or types of analogical arguments. And for example, inductive generalization, which is going to be in the section after this, which deploys statistics a great deal, inductive generalization. And then we're going to talk about causal reasoning. And then we're going to talk about inference to the best explanation, right? And along the way, some other things, some basic elements of scientific method and stuff like that. Okay, so we start with an analogy. An analogy is a similarity between 2 things or kinds of things, right? And if 2 things are similar, that means that they must have some feature in common, right? So certainly if we say that 2 things have nothing in common, then they're not similar. And if they're similar, they must have something in common. And if we ask, well, what kind of thing do 2 things have to have in common in order to be similar? We're going to say it has to be some feature, right? Some descriptive feature. It's got to be something about one which is the same as the other, yeah? And so drawing an analogy involves identifying these common features, right? Not just asserting that the 2 things are similar, but actually identifying which features they have in common and the way in which they are similar. Right, so once we identify the ways in which 2 things are similar, the question is, how do we use that, right? So one way that it's used often is as a poetic device, right? But that doesn't really pertain to the aim of thinking and critical thinking, yeah? Unless that poetic device is a means for clarifying an idea, in which case it does pertain to critical thinking. So in any kind of argument, proposition is going to be using some terms, and the terms have to be understood, right? We have to understand the meaning of the terms in order to understand the meaning of the proposition, right? And if we don't understand the meaning of the proposition, we won't know what the conclusion means, right? Or be able to evaluate the argument at all. So to clarify an idea is important, right? And sometimes we can use analogy to clarify what the meaning of a term is, and basically, bring ourselves to an understanding of what's being talked about in the first place. Okay? Analogy is often useful for that, because if there's something that we already understand, then if it has a similarity to the other thing that we don't understand, we can use that similarity, right, as a kind of a bridge. Yeah. Okay. And that's particularly in the case where we are making analogies between things that we experience and observe, which are usually easier to understand, and abstract ideas that we aren't able to observe. And there seems to be some kind of natural matchup between certain images or observed things and certain abstract ideas, right? So that some are able to represent or sort of symbolize, right, the ideas. Okay. The other way that we can use analogy is to form a hypothesis, right? So that if we want to, in scientific method, we first form a hypothesis and then we start to test the hypothesis. So in that case, we are like not really making an argument because we're not mustering evidence for a conclusion, but rather we are setting out a conclusion as possibly the case and then asking ourselves what kind of evidence we would need in order to confirm that or disconfirm it and then search for that. So it's a different process, right? But in order to form the hypothesis, oftentimes we see some kind of feature in common, or we draw some kind of analogy between something that we already know and the unknown thing that we're, investigating. And if they have the right kind of similarity, then we might use that to postulate the hypothesis, right? We might postulate that, well, what we know to be true about A is also true of B, right? Since they're similar in other ways. And then we will, go and form the hypothesis on that basis here. So we've already alluded to the structure of an analogical argument, right? That is to say that we are going to project some feature to B on the basis of the fact that some A has that feature and that A and B are similar in a certain way, in a certain other way, yeah? And when we construct an analogical argument, that's what we are in fact going to do. Now, these number 2 and 3 here, right, which are relevant to critical thinking, they are not relevant to bringing evidence to prove something. They're relevant to critical thinking in other ways, right? So the only way in which the analogy is relevant to ascertaining the truth or proving the truth of something is with regard to its use as an argument, yeah? Okay, and that's when analogies function as evidence, okay? So, and an analogical argument has this kind of form, yeah? We say, for example, about two things, X and Y. We say that X has attributes A, B, C, and D, and E, right? And then the second premise will say that we know that Y has attributes A, B, C, and D, and then we'll conclude that Y also has E, right? So you can see here that we have two things and we have two premises, right? Essentially, the two premises establish a kind of similarity between X and Y, right? And that similarity is established by asserting a certain set of features for both of them that are the same. Except for in the first case, we know that X has some feature E, which we don't know about with regard to Y. We don't know whether Y has E or not initially. But then we conclude that Y also has E on the basis of the fact that Y has so many other features that X has, right? Okay. So now we have some terms, right? The two things that we are comparing are going to be called analogs. So we have our base analog, in this case that's X, right? That's the thing that has the target analogate, yeah? The target analogate is the feature that we are concluding that Y has. So we have a base analog with a group of features including, right, the target analogate. And then we have another thing, target analog, Y, that has all the base analogates as well, yeah? So the target analog and the base analog have all the base analogates, yeah? Whereas only the base analog has the target analogate, and then in the conclusion we're going to say, oh, okay, the target analog also has the target analogate. Those are some terms that are used. It's not clear how useful they are, but they might become useful later, yeah? Anyway, the strength of the argument depends on the relation between these base analogates and the target analogate. Yeah. Or in other words, the strength of the argument depends on the relation between the features which the two things have in common and this other feature that we're investigating. Okay? So here's some examples along with some rules of thumb regarding evaluating analogical arguments. Now, again, you always have to apply these rules in a context, and you have to be open to the specifics of each context and how those specifics may actually be relevant to your evaluation, right? And how those specifics may be relevant to how these rules apply. And we're going to see how some of that works. We're going to start with the most simple idea here. That's to say, generally, the more characteristics that the two analogs have in common, or in other words, the more base analogates there are, the stronger the argument, right? So compare these two arguments. The first one is that Aisha and Fatima were both sick today, right? That's one premise. And then the second premise is that Aisha has the flu. So then we conclude that Fatima probably also has the flu, right? So they really only have one thing in common. That is that they were sick today, right? And then we know that Aisha has the flu, which is an added feature, right? The specific sickness that she has. And so we conclude that Fatima probably also has the flu, right? So we do have some reason to think that Fatima probably has the flu, but the only reason is that Aisha also was sick and that she has the flu, right? Now, if you compare that to B, you'll see how B is stronger, because here we have a lot more features in common. Aisha and Fatima were both sick today. Aisha had fever, a runny nose, and a stomach ache, and the doctor said she has the flu. Fatima also has a fever, runny nose, and a stomach ache, so she probably also has the flu. So now we have a greater number of specific symptoms which they both share. So that's more things in common, right? And, well, there are more things that we know are relevant to the flu. So that argument's stronger because, as the rule here says, the more characteristics the two analogs have in common, the stronger the argument. But of course, that says generally, because it's not a hard and fast rule. There are always circumstances where the rule doesn't apply in the same way, but it's not possible to make a rule that will tell you when and where it does or does not change its application, because the ways in which things can be different are not sort of limited, right, to what we can sort of list in any way. Yeah. Okay. So here's another rule of thumb. Generally, the more analogs that have both the base and target analogates in common, the stronger the argument, right? So now it has to do with the analogs. These are the actual things that are being compared. So, for instance, if I say I have one student from the English department in my philosophy class, and she did very well, since you are from the English department, you will also probably do well in the philosophy class. I have two analogs that I'm comparing here. One previous student from the English department, and then a current student from the English department. Yeah. So here are two analogs that have the base and target analogates in common. Yeah. I'm sorry, they just have the base analogates in common. In fact, right? Because there's only one student that has those two. Right, one student that I know of that was in English department and did very well. So in the second case, I have dozens to refer to, right? I have had dozens of students from the English department in my philosophy class, and they all did well. Since you are from the English department, you will probably also do well. So here I have many analogs that share both the base and the target analogates. And so it seems like my evidence that you're going to do well, or my belief that you're being from the English department is a sign that you will probably do well, is much stronger because the evidence that I have is much stronger because I've had dozens of students and they all did well rather than just one, right? Okay. That's easy to know. That's generally, again, the more analogs that have both the base and target analogates in common, the stronger the argument. All right. So now we have the third rule. The more diverse the base analogs, the stronger the argument, unless the base analogs are similar to the target analogs. So compare these three. I have known 7 people who owned 1990s model Chevrolet Luminas, and they all drove reliably for a long time. I just bought a 1991 Impala, and since it is also a Chevrolet, it will probably drive reliably for a long time too. Right? Okay. So here, right, how diverse are the base analogs? Well, the base analogs are these, Chevrolet Luminas that drove reliably for a long time. and they are all 1990s model Chevrolet Luminas. Yeah. So the second case, I'm saying a friend of mine drives a 2012 Mitsubishi Pajero, and another drives a 2010 Mitsubishi Nativa, another drives a 2009 Mitsubishi Lancer, and another drives a 2008 Mitsubishi Galant. None of them had any car problems. So if I buy this new model Mitsubishi Grande, I probably won't have any problem either, right? So you see, this one in the second case is stronger because of the fact that, well, in the first case, I'm buying an Impala and not a Lumina, right? So I'm essentially concluding that this Chevrolet Impala will also be reliable because every Chevrolet Lumina that I know of, or 7 Chevrolet Luminas from the 1990s that I know of, all drove reliably, right? So it's not the same exactly because it's a different model. And I'm concluding that since it's made by Chevrolet, right, it has that in common. But I only know that the Chevrolet Luminas were reliable, and I don't have any evidence about any other Chevrolets. Whereas here I have a variety of different models of Mitsubishis, right? The Pajero, the Lancer, the Galant, right? And from different years. So I have a diverse sample of different Mitsubishis, and they were all reliable. And therefore, that gives me stronger reason to believe that this different Mitsubishi model will also be reliable because I have evidence that a wide variety of Mitsubishi models were reliable. Yeah, it could be that Chevrolet just made one good car and the rest are crap. Yeah, so in that case, in fact, the fact that that Impala is a Chevrolet too doesn't give me a lot of evidence to think that the Impala will be reliable. Whereas if I have a diverse range of different models of that company's car, then I would have stronger evidence of the reliability of, some additional model from them. Okay. So again, that's an example that the more diverse the base analogs, the stronger the argument, unless the base analogs are similar to the target analogs, right? So you see, because the Impala is not exactly similar to the Lumina, they're different because it's a different model. Same here with the Grande and the other Mitsubishis. So if I go to another example, right? Let's say I have 6 friends who all drive new model Mitsubishi Pajeros, and none of them ever had a problem. So if I also buy one, I probably won't have any problem with it, right? Now, in A, the base analogs, as we saw, are not diverse. So all of them are 1990s Impalas. And the target analog is different. It's not a Lumina, but an Impala. So here I am trying to predict the reliability of a 90s model Impala based on the reliability of 7 90s model Luminas. And this is weak because even though Chevrolet made all of them, it's possible that in the 90s Chevrolet only made a few reliable cars, including the Lumina, but that the rest, including the Impala, were bad. So in B, the base analogs are diverse because they include 4 different models of Mitsubishi. They are different from the target analog, the Grande I am thinking about buying. And this argument is stronger than A because of the fact that 4 different models by Mitsubishi are reliable. Is stronger evidence that Mitsubishi generally makes reliable cars, which would include the Grande. Thus, when the base analogs and the target analog are different, the diversity of the base analogates strengthens the argument, right? But now in the C, right, where I have buying a Mitsubishi Pajero, and I have 6 friends who all drove Mitsubishi Pajeros, right? Here, the analogs are the same, right? It's a Mitsubishi Pajero in both cases. And so since the target analog, the car I'm thinking about buying, is also a Pajero, then this argument is stronger than the previous 2, right? It's stronger than it would be if the base analogs were diverse, right? So since this is a Pajero, the argument is stronger if all the other 6 friends I have actually drove the exact same kind of model of Mitsubishi Pajero that I'm thinking about buying, right? Whereas if I was buying a Mitsubishi Galant instead of a Mitsubishi Pajero, then my argument would be stronger if my 6 friends had all drove different Mitsubishis and had no problem. Yeah? Okay. The more specific the conclusion, the weaker the argument. Because the more specific conclusion is like a smaller target. And the more general conclusion is like a larger target. It's clearly less likely to hit a smaller target than a larger one. So look at these 3, A, B, and C, where A is more specific than B and B is more specific than C. So A says the last jug of Safi brand skim milk we bought went off exactly 5 days after its expiration date. So this new jug of Safi brand skim milk will probably go off exactly 5 days after its expiration date. Yeah. Now the B and C have the same premise but a different conclusion. So the conclusion of B is that this new jug of Safi brand skim milk will probably go off within at least a week after its expiration date. And C says this new jug of Safi brand skim milk will probably go off within at least 2 weeks after its expiration date. So you see that in each case there's a lot larger, let's say, margin, right, within which it can go off and you can still be right. That the difference here is that we have a conclusion which is like really general and another conclusion which is really specific. And the more specific we get with our conclusion, the less likely it is to be true, right? Okay. All right, generally the more relevant the base analogates are to the target analogate, then the stronger the argument is. So we can go back to some car examples, yeah? Several people I know bought their brand new model cars on a Wednesday, and they have been reliable. I bought a 20-year-old used car last Wednesday, so it will probably be reliable. Well, that's kind of silly, right? Because it doesn't seem like what day you bought the car on has anything to do with whether it's reliable, right? And so even though several people I know bought their brand new cars on Wednesday and they were good to go, that fact doesn't seem to mean anything, right? In the same way that it would if they all bought the same kind of car, yeah? Okay. So I have 6 friends who all drive new model Mitsubishi Pajeros, and none of them ever had a problem. But all their Pajeros are red, and this new model Pajero that I'm going to buy is black. So the fact that they never had a problem isn't good reason to think I won't have a problem with this one because this one's a different color, right? So it might be less reliable. Well, normally we don't think that the color of a car is relevant to how reliable it is, right? We think that has to do with, how well the engine is made and stuff. So, right, we wouldn't think about that as an issue here that would make a difference, right? So we have 2 things, right? One which is a similarity which is not relevant, and another which is a difference that's not relevant to the strength of the argument, yeah? And so, well, those are obvious ones because these are ones that we think of as clearly irrelevant, but sometimes things are not so black and white, and we have to ask actually how relevant it is and in what circumstances. So how do we determine what analogates are relevant to what other analogates, right? What features are relevant to which questions? Well, that's another topic that we have to discuss for, in the later section. Some might be established by way of inductive generalization, and others may be established by way of causal reasoning, different methods of causal reasoning. But the complicated thing about it is that in both of those cases, we are dealing with, as we're going to see, we're dealing with sort of forms of analogical arguments. And so it becomes a little bit, a tricky question and something interesting to think about, but in the process, we're not going to actually give you clear and fast rules that work in every case. But what we are going to do is show you some methods and then show you many considerations that have to be taken into consideration whenever we use those methods.